In this video, I'm going to demonstrate how to reduce false alarms. Now, I happen to be using an IDS alarm system. It's not my favorite, but nevertheless, the principles remain the same for other alarm systems. Now, just to give you an example of the size of this alarm, for example, if I'm going to just bypass a zone, just to give you an example, how many zones we've got active here, I literally have 63 zones, and some of these are actually smoke detectors and so forth. So I've fully utilized this panel, this alarm system. So you're looking at an alarm with over 60 zones. So how do you keep this thing stable? Right, let's go through the methods of reducing false alarms. Okay, number one, starting with the sensors. Insects, different types of bugs, spiders, and that crawl over these sensors. They like to live at the back. It doesn't hurt to just spray some insect repellent, especially if you're going on holiday. Spray some Doom or Raid, and it doesn't bother the sensor. Especially get it in the back and give it a wide spray, and you're covered. So now no hohos, no insects are going to crawl on that thing. Remember, a spider crawling over the front of it, even though the spider's cold-blooded, it will activate that sensor. So that was number one. Right, I'm now outside looking at a PIR. Same story. You can spray it. You can use various poisons to spray it. Even the big PIRs, you can spray them. In the corner there, you can see a TACX, and you can spray it. Right. The next thing is opening the sensor will allow you to see that each sensor usually has a sensitivity adjustment. For example, this one has low, medium, and high depending on where you put the jumper. So if you jump it, say like that, it's low. If you jump it like that, it's medium, and if you just leave it like that, it's high. So that is also a way of reducing false alarms. Right, so I just got the Optex RX Course Series RX CST installation manual just to show you that in the manual it does show you the zones of protection, the distance and the angular detection zones. But what I'm trying to demonstrate is that each sensor does have a sensitivity aspect. Now, I did show you in the video how you manually change that, and on this Optex it happens to use a high, low, and medium, which is kind of a discrete sensitivity adjustment. You will see the TACX, for example, uses a potentiometer which you adjust, and it's more of an analog fashion. So what will happen is if you set it to low, it will require more violations to take place before the alarm will initiate a trip signal or an alarm signal. And obviously, if you want absolute protection in terms of the most sensitive, well, then you'll leave it on high. My recommendation is if the sensor keeps tripping for no reason, well, not for no reason, but for the wrong reasons, well, then start adjusting the sensitivity. Now, some sensors don't have low, medium, and high. They have something called pulse count. 1, 2, 3, or 2, 4. And what happens there is you'll adjust it, and then it needs to count. That will be 1, 2. Then it will only activate. And some, maybe you'll have 3. So it will be 1, 2, 3. So that is another way of reducing the sensitivity and also making your alarm more reliable. Now, adjusting the sensitivity on the outdoor sensors follows a similar principle. You'll open it up. I'll just demonstrate to you. This happens to be an Optex. It's called a FIT. And when you look inside, you'll see some dip switches. And by looking at the instructions, you'll see that it's got their PRRS sensitivity happens to be number 3, and it's standard or low. So that also reduces false alarms. PRRs have a similar principle. You open them up and you will see a sensitivity adjustment, low or high. When you're looking at the TACX, this type of sensor, if it looks like this, when you open it up, instead of having a instead of having a dip switch, you will have a potentiometer, which means a variable resistor that you can rotate like so, adjusting the sensitivity. That will also reduce false alarms. Right, now on the TACX, this happens to be the TACX, the sensitivity adjustment is done here using a potentiometer. So you'll rotate it, and then it also has a pulse count, so you can adjust the amount of triggers before the alarm activates. So on the side here, it actually says their pulse count, 1 or 3. So there are two aspects here. You can change the sensitivity and you can make it have an additional pulse count. I do have extensive videos on how to set these up, so I'm not going to get into a lot of detail on that. Let's move to number 3. Right, the next one is to do with wiring. You can see what a job, or you can see how poor this job is. You see these people who wired this alarm left these loose. So every time you're opening and closing this curtain, you see this is hidden, and this happens to be the door sensor. There's the magnet. And every time the curtain is pulled, it's actually bumping this, and it's actually going to cause this wire to break. So I'm going to just fix this. This is a problem. When you see the wires loose like this hanging out, then you know, poor installation. It should at least be in this container or glued down. You can see how it's already come off here, and not a good situation here. Okay, right. What are you looking at here? Now, this is an installer this is a rafter, and what happened is, all the wires from all the sensors, but look at this. Instead of actually tying it up neatly, they just hide it behind the rafter. Why is that a problem? Number one, birds. Birds come, they nest, and they actually interfere with your alarm wiring. Number two, what happens if somebody comes to do an additional installation? They will then, maybe they bump this. If you look around here, you see there was some gas piping that was installed. There we go. They bump it or they pull on a wire, and all of this comes out. So this is another source for false alarms on the topic of wiring. You can see that instead of using solder, what installers often do is they just twist the wiring, and okay, it's fine, but often these little covers fall off, and this wire could touch that wire, and we could have a short circuit, or maybe if somebody pulls this, it could be an open circuit. So this is not a good method. This eventually will lead to false alarms from birds, and as I said, people coming to do additional installations. My advice, put this in a junction box, or tape it up. Use some high quality tape. You can use Nitto. You can still hide it there, but most important, do not leave wires like this. I mean, these things just pop off, the wind, even bugs eventually, ants get in there, and it's a problem. Right, so I'm going to solve this problem. Right, so it's taped up in there, and remember that rats also eat wires, and one's got to be mindful of those type of pests. Right, now another source of false alarms also on the wiring happens to be the jacket of the wire. For example, if you look in this terminal, you will see that the jacket is actually inserted into the terminal. So let me take it out and show you what happens. The installer has actually inserted the jacket into the terminal and actually has screwed it into the jacket. So what happens is when the terminal squashes the wire, it's actually squashing on the jacket as well, and that is a source of false alarm. So just remember that when you do install the wire into the terminal, make sure that the jacket does not go in the terminal itself. So the jacket must be on the outside, and only the copper must be on the inside, just like that. So you can see there's the jacket, but the jacket comes to an end just before the terminal mouth, and that will stop false alarms. Now, as you can see, there's a dog here, and that dog is definitely within the specification of both the TACX, which is the sensor over here, and the Optex VXI, which is over there. So this animal over here, in terms of the weight category, should not set off these alarms. Yet both these sensors have activated because of this size animal, and the reason is is as follows. This dog, as you can see, is a small dog, small breed dog, and can run around the garden as many times as he wants and he won't activate the alarm. However, upon chasing a cat, the alarm will activate. And that's what people forget, that the dog may not be alone. So if you measure the dog and you add another dog after him, then this dog can actually activate the alarm, especially when running at a high speed going up the slope. And you'll see later in the video about the problem with the slope and the PIR sensors. Here we have a PIR on this pillar, or this little outcrop of a wall, and it is installed at a fair height. That height is fine, but it will false alarm, especially for large birds. And there's a reason for why it will do that, and that has got to do with the ground plane. Now if you look, as I pan the camera, you can see that the ground plane has an incline. Right, so on this slide I'm actually showing you that I have a VXI here, and this is a 90-degree VXI. The Optex is in the process of making a 180-degree VXI. So just to show you the zone of protection, you're getting 12 meters in a 90-degree shape like that. So we've actually measured it, and it's about like this. Yeah, that's it. So that's your 90 degrees, and all of this is now covered by this sensor. Now what the problem is, this this land here actually slopes upwards. So if you took a horizontal line and you went like this, you'll actually find that the distance from the ground from there to the horizontal might be 1 meter, but somewhere over here you might find that it's 600. Now why is that a problem? The reason why that's a problem is the sensor, I'm going to draw it here, let's get some, the sensor sends out a low, well, it's sensitive to a low zone of protection. So if there's any movement in the low area, and that goes to about 12 meters. So you're looking at about there. But then it also is sensitive to a higher, that color is not going to work. It's also sensitive to a higher zone. And what happens is when you break the zone, both zones, then the alarm activates. So if you're standing over here, you literally need to be off the ground 1 meter, and there you go. You're going to break that zone of protection. And you can see this one's actually a little bit lower, by the way. So what happens is you need to break both of these detection zones in order for the alarm to trigger. So that would mean you'd have to be literally 1 meter off the ground, or a very big animal over here, very big, I mean like a really big dog. But however, if you're over here in this area, you can see that your size is now less than half because of this incline. So because of the incline in the land, therefore the detection zone actually is allowing for a smaller or more sensitive outcome. And that is why when you're installing a PIR and the land is going up, you have to take that into consideration, because a large bird, now we have something called a hadedah, which is a bird which measures about 30 to 40 centimeters, but when it opens its wings, easily will break both of these. It will either easily be detected in both of these detection zones, and therefore, yes, you will get a false alarm when you install a PIR and the land is at an incline because of this principle I've just explained. Right. Also looking at the PIRs, this happens to be the fit PIR, and this is a slide just showing about the placement. Now you can see that this fit, you've got one facing there, you can see it's got the dual beam, when I say dual beam I mean dual detection zones. You can see that it's going to do that, and this one is going to do that. Right, so this one is fine. This one over here can false alarm.
Now I'll explain to you why it can false alarm. There goes the first beam or detection zone. And here goes the second one. Let's just do that like that. It's actually more like that. Now, the person who installed this may not have accounted for birds or animals, maybe a cat, that actually would walk on this ledge. So, believe it or not, you might have a cat on this ledge, and look at that. The cat is actually long enough or high enough to break both of these detection zones, therefore activating the alarm. A bird that is sitting here, even though cold-blooded, when it opens its wings and flies away, if the bird breaks both of these zones, then it will activate the alarm. So therefore, a false alarm may be initiated. And the reason why I have this in my presentation is because it did initiate a false alarm. And that is why you can see this window is closed, because of cats walking on ledges to get to kitchens and foods. Anyway, okay, in this slide, you will see there is an HX80. Now, HX is the optics range for the high mount, and it should be mounted at least 2.8 meters above the ground plane. Now, as you can see, this is the ground plane. Now, yes, I know that is an obvious point I've just said, but I'm going to explain to you why this car parked here will create false alarms. Now, let's just work this out. This happens to be installed at 3 meters, which is fine. That is part of the specification. In fact, the higher you mount it, the longer its detection zone is, but to a point. Don't start installing it at 5 meters and things like that. That's useless. It's got to be installed lower than, I think it's 3 point, I'm not sure if it's 3 meters, I think is actually the max. So you can install from about 2.5 to about 3 meters. Now, how this sensor works is as follows. Let's get 2 colors here. It has a detection zone that looks like this. Sorry. And so forth. And let's get the secondary one. Now remember that, let's try a different color. Bugger. Okay. This one should have been more like that. Okay, so what's happening here is these green and purple lines represent the zones of detection. So that would mean that if you break both these zones of detection, then the alarm will activate. So you'd have to actually be bigger than this width. Now, obviously, this is not to scale. I'm just showing you a principle. But what I want you to see is that if you look at the width here on the ground, you'll see that maybe it's 40 centimeters. But if you follow this up here to this height here, you'll see that to break these detection zones, it's half. So this is one of the reasons why the placement of the sensor is very important, because on the ground, yes, somebody walking would actually break these quite easily. But when you're looking at an angle, especially at a higher plane, you can see that the width between the zones of detection is actually reduced. So that means that if you have let's put a pen here, if you have a animal or a bird sitting here, a cat running on the top of this car, it actually false alarms. So this is an example of how the sensor has been set up without taking into account the changing aspects of this location. Now, as I said, there's the ground plane. Now, if you have the ground plane over here and this is 3 meters, it's correct. But now if you take this as the ground plane, you can see how it's actually half the distance. Now, if you installed this sensor at that height, you see half the distance, and its zones of detection were here, you would see you'll pick up a lot of false alarms, even for small movements here on the ground, and that is why it must be 3 meters. But therefore, this car being in this position is actually halving the height, because there you can see the height. So this is something that you should actually be aware of. And if you look at another picture, you can see that you would need to set this up in such a way that either you mask off this section or you don't park here. So these are the challenges when setting up an alarm system. You actually have to do a site survey, and upon doing a site survey, you would have to see where to place these sensors.
Right, this next false alarm occurs because of weather conditions. Now, you'll see I have 2 sensors. I have the Tacx on the edge of the wall, and then towards the inner of the wall, I have the optics fit. Now, the optics on the wall there is set for 5 meters. So what that means is that that sensor should only activate if somebody, an intruder, is within 5 meters of the sensor.
Okay, in this slide we have the FTN, and the FTN has a zone of detection that looks something like this, and for about 5 meters, and then the top one is about there. Now if you work out 5 meters, 1, 2, 3, 4, 5, that's about 5 meters. Now something interesting about this sensor, you see these hanging leaves here. Now these hanging leaves should not activate the alarm. Why? Because here you have the bottom zone of detection, and here you have the top zone of detection, and it should only activate when something moves in this area and something moves in this area. So you have to break both of those detection zones. But now here's the challenge. This installation was designed during the day, and what the installers didn't come to realize is that at night, with temperature changes, this detection zone actually shifts because of temperature change. Secondly, what about rain? When it rains, you find that these leaves actually drop down. So if this is the canopy of the plant, when it rains, the leaves become heavier and it drops to about that. So the branches lower themselves because of the weight of the water, and guess what? False alarm. So this actually happened, and therefore you have to derate foliage and things like that because of movement owing to wind or rain. So in the case of this tree, these little branches here, yes, they did set off this optics sensor. Because of the weight of the rain, they shifted from this level to this level, and therefore the sensor activated. Another aspect is that if you look here, you can see there's a ledge, and once again, a bird sitting on the ledge here, flying in that direction, will set off the sensor, or a cat. So these are some of the false alarms that you may be able to reduce. Cut away plants, and don't just cut it away to a point where you say, okay, well, no, it's out of the zone of protection. Realize that wind and weather, rain, weather, water will actually change the shape of the plant in terms of the way it hangs.
Right, what you're seeing is a Tacx which is positioned on the wall, and I'll show you its zone of protection. 12 meters in more than 90 degrees. Now, if you take a walk to the plants along the wall here, you would actually see that you're in excess of 10 meters. You'll find that these plants here actually do initiate a trip, and the reason is that in the night it seems like the sensor is more sensitive, and one's got to be aware of the temperature changes and how much movement is actually taking place. So when there's a gust of wind, most of those leaves actually move, and they move quite vigorously, and it's actually enough to initiate a trip on the optics sensor, and that's what I have found. So you actually have to derate it. Derate means reduce the sensitivity or the length of detection, but you have to be aware that this has to be done not just for the day. If you do a walk test in the day, you actually have to do it in the night on a cold day, or on a cold night, or on a wet day and night. So that also changes the sensitivity of the sensors if there's rain and if there's a temperature change. So many people will install their sensors and then do the walk tests and so forth, maybe in the midday, because that's the time that people would do their work during the day. But then as the temperature drops, you'll find that the sensor's sensitivity actually changes. Okay, so in this instance we have a PIR and a beam. Now the problem here is that the PIR is also sensitive to infrared beams. So that means if this PIR is open to 90 degrees in this direction, and this is a receiving beam, that means that on the other side there will be a sending beam, sending infrared waves to this beam. There will be spillage, because remember that infrared is not like a laser. It does actually have some spillage, and what will happen is it actually triggers this PIR. So that means that if you are going to do this setup where you've got a beam and a PIR in close vicinity to each other, the beam has to be the sender, and the PIR, well, that's only a single unit, so there's no additional unit that goes with this. So this thing will work fine, but make sure that the beam is a receiver and that there is no transmitting beam interfering with this sensor. And what will happen is, if you did have this as a receiver, this PRR will, and it will trigger inconsistently, which means it won't just trigger as soon as the you switch on the beam. No, it's actually unpredictable, and it may happen after 2 hours, and then after an hour, and then after 3 hours. And what happens is the spillage, the infrared spillage that comes out, eventually breaks down that sensitivity, that threshold, and then the PIR activates. And this activation is dependent on atmospheric conditions, changing in temperature, movements around the area, plants and so forth. So it is actually very unpredictable. So what I found is that if you have to put this as the receiver, then this PIR must not be facing the transmitter. So then you'd have to have this PIR facing away, because the transmitting beams, the transmitting infrared must not be able to get into this PIR. So you'd have to face the PIR away. And you might be asking, well, why would somebody put the receiver here? The answer is that, remember that the receiver is the one that's connected to the alarm in terms of the signal wires, whereas the transmitter just uses a two-wire, positive and negative, while the receiver uses positive, negative, and then the trip. So often you may not have had an extra cable in the remote location. So this is the tip. The tip is receiver must not be placed near a PIR. Right, in this instance we have a PIR. It happens to be a wireless PIR on the pillar of the wall, and right in the line of sight of this PIR happens to be this plant with these big fleshy leaves. Now while the PIR is only supposed to be sensitive to heat, i.e. humans and dogs and so forth, and that plant is not hot, it's actually cold, then why does it activate? Well, it does. So what happens is, when the wind blows, then you will see that PIR activate, because this is fairly large, and therefore you should not put any big plants near the PIR. In fact, if you have to have a tree or a plant in the way of the PIR, what you need to do is to mask it. You can then block off that section of the PIR's zone of protection where the plant is, or just cut the plant back a bit. Right, now you see a PIR, an indoor PIR in the corner there, and this happens to be in a garage. And a common false alarm in garages is, number one, the garages often get hot. So the PRR does not necessarily operate in the same way as it would be indoors as it is in an indoor garage. I mean, indoors in a house where there's correct roofing, whereas in a garage you can see here the roofing, there's no isolation, so it gets pretty hot in the garage. The next problem, the next challenge to that sensor is in garages there's often rats and vermin that crawl around, and they can set off that sensor. So my advice is in garages and areas where it is in roofs, some people do put passives in roofs. Yes, you might think I'm crazy, but in different countries the crime is very high. Such as South Africa, you can put a passive in the roof because people lift up the roof tiles and they walk and they try and break in through the roof. So there are houses where we do put passives in, but then the temperature is very hot in those environments and there are rats. And obviously the sensors are not installed in the correct heights. So what you got to do is you got to match the sensor for the environment. So if you are going to use a standard indoor sensor in a garage, make sure to adjust that pulse count, because you will get a lot of false alarms in the garage. And as you know, the garage does often get rats and mice, especially through the night, because there's no movement in the garage. And therefore, I recommend that if you do install a regular PIR in a garage, set the pulse count a bit higher. Preferably use a microwave or a sensor that is actually geared for this type of environment, a roof or a garage. Right, there are some programming or configuration settings you can do to also reduce false alarms. On all the good alarms, you can set the amount of activations of that zone before it actually initiates an alarm signal. For example, here it says V22, so it's violated 22. Now you could set it that it must violate twice in a certain time frame before it initiates alarm. That you will do using the configuration menu. Now, what very good alarm systems have is a cross zoning, which means you could say, well, kitchen door, but only activate the alarm if it's kitchen door and kitchen passive. So you could say it's an AND function, that AND. Now I know they did that away, they've done away with that in the new IDS panels, which is very sad. It's one of the features that I really miss. Anyway, so on good alarms, you have these features to actually set the pulse counts or the trigger counts of the zone, but just be careful. You don't want to set that on the sensor and the alarm, because then you'll make your alarm system too insensitive to burglars, to criminals. So that means, as I showed you, on almost all sensors you can adjust the pulse count or the number of or the sensitivity of the actual infrared sensor. But if you do that and come into the alarm panel and actually change the sensitivity triggers, then you're going to have no alarming. So I hope this video was informative and I hope it was helpful. I hope you have very few false alarms, yet still have a reliable alarm system. Just from my side, I've set up several alarm systems with more than 50 zones, with all different types, tactics, optics, you name it. I only use the best stuff, and I've managed to get very few false alarms, even with large setups with birds like hardy-dars and so forth, because also birds tend to come in the early morning and then sometime in the afternoon. They're not usually there in the night. In the night the birds sleep, so you can also set up in terms of day and night if the alarm provides that option for you. Alright, so thanks for watching and I hope this was helpful.